Thanks very much. It's not really a science talk, it's a commercial promo. So next week we will have the first of what I hope will be an annual event, Atom, the Festival of Science and Technology, and you can get tickets at Mostly Books. Or you can go to the Oxford Science Festival website, which I don't recommend. What I do recommend is you should go to Amazon, find the books you want to buy, and then you go to Mostly Books and buy them. Okay, so that's the, what is going to happen. Why is it called Atom? Well, Abingdon-on-Thames in Oxfordshire in March is an obvious response. The programme, there are on the piano there some copies of the programmes, and I'll just tell you what's going to happen, and then give a little bit of background as to why and so on. So, it starts a week tomorrow at the very same time as the concert here. So those of you who have decided that rather than going to the concert you prefer to pay money or something else, that's what's going to be happening on the 20th of March. I shall tell you about that in a moment. Friday night next week, Jim Al-Khalili, who you probably will know from Radio 4's Life Scientific, who's a physicist from the University of Surrey, he will be giving a talk with the imposing title Quantum Biology, which is already making me wobble. But during the day, we will have a school science fair taking place in the Guildhall in the morning and early afternoon. And also, later in the afternoon and early evening in the Guildhall, we're going to have a Live Opportunities Careers Fair. One of the ideas we had was to try to imitate in a 21st century environment what Abingdon has become famous for. You know what happens every year in September. You can't get through the centre of town because the fair is here. And of course that is the remnant of what used to be the hiring fair at harvest time when Abingdon was in the centre of a farming community. And we thought we'd have a 21st century analogue of that, which is like a hiring fair for science and technology, where students at GCSE, A-level, from the further education college, undergraduates or even graduates, will be able to meet with people from the science and technological industries which are all around here, which I'll show you in a moment. And then on Saturday, during the day in the Market Square, there's going to be a science fair taking place with lots of hands-on activities for all the family. And also that afternoon and evening, there's a programme called Visualise, which is a magical science show. And so all the details of those are in the programme here, or if you go to the website. I'll just say some things about the first evening, because that's what I'm primarily involved with. So let's go to this. Of course, Atom could also mean Abingdon to Mars, which might be what it might be in the future. It does make a link with something here, and it's the following. But why is it that we're having this festival in Abingdon? Well, obviously because we live here, but really what I should be saying is, why has this thing not happened before? And that's a fair question, and I don't know the answer. See, Abingdon is both metaphorically and literally at the centre of UK major science. For example, around us, we're surrounded by these, just to name a few. I mean, here in town, we've got Sophos, which we all know of. In Oxford University, the Science Park, Oxford Innovation, Oxford Instruments, and so on. But around us at the south are these national and international facilities. There's Harwell, that everybody knows of for many years. There's the Rutherford Appleton Laboratory, which is the major centre for civil physics and now other areas of science, with Diamond, doing work on chemistry, biological systems. There's the United Kingdom Atomic Energy Authority just down the road at Culham. And of course JET, the European fusion reactor, is right there, just down the road from us. So Abingdon is literally at the centre of national and international science, and many of the scientists and retired scientists and their families are living here in town. So this is a natural place to have a festival of science. If those laboratories cannot do outreach through this, then somebody's missing a trick somewhere. So that's really what the idea behind it all has been. So I thought I would just focus on one of these, just for the moment, Rutherford Appleton Lab, because, well, I did spend some time working there for many years, but it also links to something that's very much currently in the news. Last year's Nobel Prize, does everybody know who that is? That's Peter Higgs, of the Higgs boson. I'm not telling you what the Higgs boson is, but that's the special camera behind him, which is one of the means that it was possible to detect the thing after this 27-kilometre round machine, underground in Geneva, CERN, smashed particles together to recreate the early moments of the universe in the laboratory to see what happened, and out of these experiments was revealed the Higgs boson. The role of Rutherford Appleton Laboratory is that this was a worldwide collaboration, and Rutherford Lab was the centre of the British input to this, and a huge amount of the technology. These detectors the size of battleships at one scale are made with little components right down to the nanoscale, and Rutherford Lab people in this town were involved in that. So there are people who have been involved from Abingdon in helping win that Nobel Prize last year. So that shows why we should have some pride here in actually what is going on. Rutherford also involved in space science, and I just thought I would show you this nice image that was just a month old. Each day they are recording with a satellite, they've built the cameras of the satellite, images of the sun. Not just the sun as you see it with your eyes, well, I don't know why you should look at it, but you get the metaphorical idea. Not just the sun that you see shining in the spectrum of light that our eyes respond to, but in all wavelengths, and different wavelengths reveal the sun in different ways. So this picture here you see was actually from the 23rd of January, and you can see some sunspots on there, and I'll now show you this in a different wavelength, and you'll be able to see what is really going on. Just choose one of those sunspots and look at that spot and compare with what happens in the next image. So here you can sort of see the violence of the sun and where those sunspots were. Let's go back. So focus on some of those bright spots down the right, for example, there, and you will see those two little black dots you might have noticed before. So this is showing how with different instruments and looking at the sun in different wavelengths, you can start getting quite profound insights into what is going on. You can feel the violence of the sun. There's magnetic fields pouring out. The sun itself is floating out around on these things. You get wonderful images which tell science. And this works. The Mac has failed us. Because we're supposed to see a solar flare suddenly erupt from about there and shoot out. A few weeks ago, well, a week or so ago, there was the wonderful aurora, which I didn't see. I don't know if anyone in this room managed to see them. But that was a result of the sun erupting, throwing out a huge solar flare, which travelled across space and interacted with our own magnetic field and gave wonderful effects. But the sun is a very violent thing. It's producing power. And one of the things which now we are trying to do is, on Earth, to create fusion power, which is essentially the sun at the middle is fusing atoms, particles of hydrogen nuclei, protons together, turning hydrogen into helium and liberating energy, which eventually appears as sunlight. It's been doing that for 5 billion years so far. The idea of this is what we would like to see achieved here for humanity, to create fusion power. And a jet down the road, the joint European Torus, is the leader in the hope for that. So here around Abingdon, this real great work is going on, and this is inside the joint European Torus. So stars, of which the sun is one, they go through a life cycle. And just to end, one of the interesting things that happens, everybody's heard of black holes, but the first stage of all of this is when the star, late in its life, if it's under certain conditions, might collapse under its own weight. Collapse inwards and leave what's called a neutron star behind. The electrons and protons that are in there just collapsing on each other, leaving neutrons in the middle, which a huge clump are making a neutron star, and throwing out stuff into the night, into the sky by what's called a supernova. So the neutron star that's left behind is made of neutrons, which are neutral, but they've got magnetism. And these things are rotating around very fast. The magnetic fields are whirling around very fast. As a result, radiation is thrown out into space. And it's like a lighthouse. So imagine I'm a neutron star, and I'm throwing out light waves where my hands go. And as I rotate around, you see it, you see it, you see it. So you see a pulsing. And that is what a pulsar is. Now, have you heard, how many people here have heard of a pulsar? Great, wonderful. How many people here know who discovered the pulsar? How many people know who got the Nobel Prize for that? Okay, right. So this is the end of the talk. So the pulsar was discovered by Jocelyn Bell in 1960, and her supervisor got the Nobel Prize. I'm not making that up. Okay, you can check for yourself. And I'm just saying this to show you just how she was then. So on the first night of the festival next Thursday, we will start with, well, me introducing the festival and giving a rather expanded version of what I'm saying here now, and then introducing Jocelyn Bell, not as she is like that, but as she is now. She's a fellow of the Royal Society, she's a Dame, she's now the president of the Royal Society of Edinburgh. So she has not won a Nobel Prize, but she has a great successful career. And as well as the fact that she is unusual in the sense of being a female in the physical sciences. That's one of the things that I want to talk with her about, is why is it that there are females in the biological sciences almost commensurate with males, but why is it there are so few, relatively speaking, females in the physical sciences? What can we do about it? And what was it that attracted her into science? What did she feel about the act of discovery? Because the one thing about science that is wonderful is if you're lucky once or maybe twice in your whole career, you actually stumble upon something that matters. And for a moment, you're the only person that knows. And there is nothing that can compare to that. It makes all the hard work worthwhile. And so hopefully Jocelyn will tell us about that. Thank you.